Hi everyone. Example 2 is pretty much the same thing as example 1. So if you think you understood it, you can go ahead and solve it and fast forward to the end and see if you get it right. Otherwise, let's get started. So remember, to find the zeros of any equation, you always make your y 0. So I'm going to start by making my y 0. So I'm going to have 0 equals, I'm just going to kind of set it up. All right, I got the -3 in the front. And then we have the x minus 1 and the x plus 4. Okay, so when you're finding your zeros, you set every single factor equal to 0. So factors are, they're numbers that multiply together. So like 3 or -3, x minus 1, and x plus 4, they are all factors. Okay, now, when you're finding the zeros, you only set factors that contain x's equal to 0. Okay, if you set -3 equal to 0, well, that doesn't really make much sense, and that's not really helping you. Okay, so I'm only going to set the x minus 1 equal to 0 and the x plus 4. So I'm going to set x minus 1 equal to 0, and I'm going to set x plus 4 equal to 0. Okay, which you can just solve this for x, or don't forget the shortcut, you just flip the signs. So the opposite of -1 is +1, and the opposite of 4 is -4. There you go. So we already know our two zeros. X could be 1 or x could be -4. Okay, so I'm going to go ahead and plot those bad boys on my graph. So I have 1 at 1. Get it? 1 at 1. Board slapper. Oh man, I cracked myself up. And 1 at -4. 1, 2, 3, 4. So here are my x-intercepts. I have one x-intercept and I have another x-intercept. Okay, now how you find your zeros? Don't forget, you can only say it's the C value when you're in standard form. Well, we are not in standard form, so I can't say that. Okay, so when you are not in standard form, you actually have to solve for your y-intercept. And we do that by making all of our x's 0. So I'm going to substitute in 0 for my x's, or transform 0 into x, and solve for y. Okay, so we have y equals the -3 times, well, I spot an x, so that x will transform into a 0. So 0 minus 1 times 0 plus 4. All right, let's see what we get. So we have -3, 0 minus 1 is -1, and 0 plus 4 is 4. And all I need to do is multiply those. So -3 times -1 is 3, and 3 times 4 is 12. So I have a y-intercept at 12. So you can say y equals 12, or you can say it's at 0, 12. And again, you guys, don't forget, you could also write your x's as a point as well. You could say 1, 0, or -4, 0. All right, let's plot our y-intercept. So it's at 0, 12. So I got to count a lot. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay! All right, so here's our y-intercept. Okay, and eventually when I draw in my axis of symmetry, I'm going to reflect that bad boy over my axis of symmetry. Okay, so speaking of axis of symmetries, don't forget, in order to find the rest of this, technically we can already find the A value, but in order to find the vertex point in our axis of symmetry, I need to convert factored form into standard form. Okay, so I need to convert that thing, and don't forget, since I have a parenthesis right beside a parenthesis, the way I'm going to convert that thing into standard form is by distributing. If you love to distribute, you will love converting from factored form into standard form. Okay, so I'm going to rewrite this real quickly. So we have y equals -3 times x minus 1 times x plus 4. Okay, so for the time being, I'm going to distribute these two parentheses together. I'm going to ignore this -3 until the very end. Now, it is not wrong to distribute the -3 to the first parenthesis and distribute that to the next parenthesis. Now, what you can't do, you cannot distribute -3 to everything. Okay, usually what I like to do is I like to ignore it and distribute these. And then at the very end, whatever I get, I'll distribute -3 to that. So that's the way I'm going to approach it. So I'm just going to ignore my -3 for now. So I'm going to write y equals -3. Okay, and whatever I get in here after I distribute, then at the very end, I'll distribute -3 to all that. Okay, well, let's get to distributing. So I'm going to start with the first term and multiply it to every single term in my second parenthesis. Bam and bam. So x times x is x squared. You add the exponents. Remember, there's secretly a 1 here. 1 plus 1 is 2. And x times 4 is 4x. Okay, and now I'm going to multiply -1 to every single term in that parenthesis. So -1 times x is -x or -1x, whatever floats your boat. And then -1 times 4, well, that's -4. Alrighty, I'm going to combine my like terms real quickly. I'm going to bring this up here. So you have y equals -3 times, let's see what we get. Alright, I only have 1x squared, so I'm just going to bring that on over. 4x minus 4x. Don't forget, when you add like terms, don't touch the variables and their exponents. Leave them alone. So I'm going to add 4 minus 1. 4 minus 1 is +3. And I'm just going to bring the x with it. All right, and then my final term doesn't have any other like terms. So I'm just going to bring on over my -4. All right, so from here, after I distribute these two parentheses, guess what? Now I have a -3 on the outside of this parenthesis. What do you guys think I'm going to do with the -3 on the outside of this parenthesis? Holy hot dog, we're going to distribute it to every single term in this parenthesis. So pretty much we're just doing lots and lots of distributing. All right, let's do it. So -3 times x squared is -3x squared. -3 times 3x is -9x. And -3 times -4 is +12. Okay, so now I can identify my a, b, and c. My a is the number in front of the x squared, which is -3. The b is the number in front of the x, which is -9. And the c is the number on the end, which is 12 without the x. Okay, so now that I have standard form, if you guys see again, now that we're in standard form, you can see that the c value is equal to my y-intercept. So that's a good way to check yourself after you convert to standard form. Okay, so now from here, I need to find the axis of symmetry, which will be the h value in my vertex point. Okay, well, let's get started. So I have -b, or the opposite of b, which the opposite of -9 is +9, over 2 times a, which is -3. So this will be 9 over -6, okay, which, let me just check one thing. Just want to make sure I'm doing everything right. Yep. All right, and then 9 over 6 can reduce down. Do you guys know a number that will divide into 9 and 6? Of course you do. It'd be 3. So I'm going to divide each of these by 3. Okay, so my x will be equal to 9 divided by 3 is 3. And -6 divided by 3 is -2. So we have -3 halves, or -1½ is the axis of symmetry. Okay, so I'm going to go ahead and draw that in. And don't forget that value is the same as the h value in your vertex point. So I already know the h value is -3 halves. Okay, and -3 halves is 1.5, or 1.5, 1.5. Okay, so it's -1.5. And I just want to, let's see here, 1, 2.5, 1, 2. Yep. Okay. Which if you see, it's the halfway point between the zeros. So it makes sense, right? All right, we got our axis of symmetry in here. All right, so from here, now I need to solve for the k value, or the y value, of the vertex point. And remember, we do that by substituting in our x value into standard form. So everywhere I see an x, I'm going to transform it into a -3/2. And have fun, you guys. We have a fraction, and fractions are our friends, so it's going to be swell. I already know. Okay, so we have -3 times x squared, which my x is -3/2. And then we have -9 times x. So -9 times x, which will transform into a -3/2. And then plus 12. Okay, now I'm going to go ahead and write my numbers that aren't fractions as fractions to help me multiply. Which remember, numbers that don't look like fractions are always secretly over 1, so keep that in mind. All right, so don't forget, do we do multiplication? These two are multiplying. Do we do multiplication before we do exponents, or do we do exponents before we multiply? Well, if you think back to order of operations, you got to do exponents first. So I'm going to square the -3/2 first, then multiply it to the -3. And remember the shortcut, you can just square the numerator and denominator. So -3 squared, -3 times -3 is 9. 2 squared, 2 times 2 is 4. All right, and then here I already have a fraction being multiplied, so I'm just going to go straight on across. Go straight across when you multiply two fractions. Don't cross multiply. That's when you have a fraction equal to a fraction, like when we did proportions, so be careful. Okay, -9 times -3 is -27. 1 times 2 is 2. And then I'm just going to bring on down that 12. All right, I'm running out of space, so I'm going to continue over here. All right, over here, I'm just going to multiply straight on across again. So -3 times 9 is -27 over 1 times 4 is 4. Now, if we're trying to look in advance, I know I'm going to be adding some fractions together. What must you have first before you can add fractions together? Holy hot dog. You must have a common denominator. Okay, which if you see here, I have a 4, a 2, and then the 12 is secretly over a 1. So what is the smallest number that multiplies be 1, 2, and 4? Well, that would be a 4. So my common denominator is going to be 4. So this fraction's already over 4. I just need to force these two to be over 4 whether or not they want to be. I'm going to be kind of mean. So I'm going to do it over here to save some room. So what do you multiply 2 by to get 4? You would multiply it by 2, which don't forget, if you multiply it to the bottom, you got to multiply it to the top. Okay, and then here, 1 times what will give you 4? Well, that would be 4, but don't forget, you multiply it to the bottom, you got to multiply it to the top. And now that I have fractions being multiplied, I'm just going to go straight on across when I multiply. So -27 times 2 is going to be, let's see here, 14, -54, pretty sure. I'll double check. Yeah. And then 12 times 4 is 48. All right, so let's see what happens. Let's see here. For some reason, that doesn't seem right. Hold on, you guys. Sorry, I'm having a moment. I see it. You guys probably already saw it, didn't you? Yeah, you're like, Miss Long, you're not very smart right now. Sorry, guys, I'm having a moment. Up here, I should have noticed this. A negative times a negative is a positive, right? So this should have been a positive. So all that's going to do is change this to a positive. Okay, it really didn't do much. So I'm glad I caught that. Pretty much, you guys, the most important thing in math is if you can catch your mistakes. Because there's not one person I know that's done every math problem right. So if you see I just messed it up, but I caught myself, so we're good to go. Okay, so now this will be making more sense. So 27 subtracted from 54, well, that's going to be, let's see here, 24 plus 3, I think it's 27, yes. 27 times 2 is 54, I'm pretty sure. Yeah, so that's going to be 27 over 4 plus 48 over 4. Okay, which 27 and 48, that's going to give me, let's see, So 48, 58, 68, 78 minus 375 over 4. There we go. Okay. Just double check everything. Yep. Okay, so my K value is going to be 75 over 4. Holy hot dog. That was a blast, wasn't it? Fractions are our friends. So I had a blast hanging out with one of my friends. Okay, so again, now we need to plot our vertex point. Negative 3.5, or negative 3 halves, is negative 1.5, or 1.5. Okay, 75 over 4, well, that's going to be slightly over 18, because 4 goes into 7 once with the remainder of 3, and 4 goes into 35 a little bit over 8 times. So we know it's going to be a little bit over 18. Guys, and don't forget your vertex point should land on your axis of symmetry. Okay, so I have negative 1.5, then 18, slightly over 18. So it's going to be somewhere up here. So this is my vertex point right here. Okay, and even without knowing the A value, you can kind of already see kind of where your graph is headed. Also, don't forget, you guys, I completely forgot. Don't forget to reflect over your y-intercept after you graph your axis of symmetry. So my y-intercept is 1.5 spaces to my axis of symmetry, which means when I flip it over, it'll be 1.5 spaces over. So it'll be a total of 3 spaces from the origin. So 1, 2, 3. So it's going to be 3 over, so about right. Let's see, 1, 2, 3. Somewhere about right here. So higher up, because my liner is somewhere over there. Sorry, that was a really embarrassing point. Hopefully yours looks better than mine. Okay, so the last step is to find the A value, which will tell us if it's a max or minimum, which you can kind of already tell it's kind of facing down if you were to trace it, but it doesn't hurt to just verify that with what makes sense. So our A value, remember the A value is the number in front of your parenthesis in factored form, or your leading coefficient of standard form, which is a -3. So the A value is a -3. So we know it's a negative graph, or a negative A value, so A is less than 0, which means it's a sad graph. It's negative, which means it's sad, and that means it has a maximum. Which makes sense, because our graph kind of looks like that already. Alright, you guys, the final step. Let's plot these points and connect them, which I already plotted them, so let's connect these points. Alright, let's do this. Hopefully I do better this time. Okay, got one. And then, let's see. There we go. Look at that beautiful parabola. This whole problem's been like a work of art. Like, I could frame this on my wall. It looks so awesome. All right, and then actually your final step is to name your graph, which is the most important part of the whole problem, right? So let's see here. My graph's name is going to be named Chester. I like that name. It looks like a Chester, too. All right, you guys, that's how you graph from factored form. So we've learned how to graph from standard form, from factored form, and in a little bit you'll learn how to graph from vertex form. It just keeps getting better, right? All right, well, let's get started on some vertex form. I'm already super pumped up. Let's do it, you guys.